Hi, this is the book problems from section 9.2, page 571, and we're starting with number 39. Local high school makes a change that should improve student satisfaction with the parking situation. Before the change, 37% of the school's students approved of the parking that was provided. After the change, the principal surveys a simple random sample of 200 of the over 2,500 students of the school. In all, 83 students say that they approve of the new parking arrangement. Principal cites this as evidence that the change was effective. Perform a test of the principal's claim at the alpha equal to 0.05 significance level. So, reading back through the problem, of course you normally would circle numbers and highlight what they mean, but this is the textbook, we're not allowed to do that. So, reading through, I have 37%. That is my proportion. You can put that little 0 there, meaning it comes from the population, is 0.37. And the simple random sample has a sample size of 200, and 83 of those 200 said that they approved. And they also told you that the sample population was 2,500. You don't really need to know that unless you want to say that 200 is less than 10% of 2,500. And we want to test at the alpha equal to 0.05 significance level. I'm going to zoom out now that we know the problem. We have to do the state plan do conclude. So state. First, define your parameter, P, as the proportion of students who approve of the new parking arrangement. Then as part of our state, we need to write the hypotheses. The HO, the null hypothesis, is just that the proportion is going to stay at 0.37. That no matter what the principal did, there's no difference, there's no change. The alternative is saying what the principal is hoping for, that things have improved, so that the proportion is greater than 0.37. So that's enough for our state to get an E. Now we have to do the plan. We have our assumptions and conditions. First one, we're told that we have a random sample. We have a random sample of 200 students. Next, we're dealing with proportions, so we need successes and failures, some that do and some that don't. We have to use the population proportion of 0.37 times 200. That needs to be greater than or equal to 10. It's actually equal to, calculator, 74. So 74 is greater than or equal to 10. At least 10 students approve. And then I also need that 1 minus 0.37 times 200, which equals 126. It's greater than or equal to 10. So I have at least 10 students approve and at least 10 don't. Do not approve of the new parking arrangement. Now, one of the most important parts that a lot of you tend to forget is writing why we use these conditions, or check them, with conditions met. We can apply the normal model and conduct a one proportion Z interval for, looking back at the book, oh my goodness, I just messed up, silly me, and conduct a one proportion Z test. With alpha equal to 0.05. You don't have to say that alpha equal to 0.05, but they gave it to us, so we might as well. Now for the do part, I'm doing my one prop Z test. I've already named it, so I don't have to name it again. And I'm just going to go to my calculator and plug in my information. So once it lightens up, there we go. I'm going to go stat test, one prop Z test, and the student body was 37%, so the P0 is 0.37. I had 83 out of 200 say they approved it, and the principal's looking to see that things have improved, so it's greater than, and calculate. So we have a z-score of 1.318, p-value is 0.094, they already gave us our p-hat, and our sample size. So I need to copy all that information down onto my paper and draw a picture so it makes sense. I have a z-score of 1.318, my p-value is 0.094, and my p-hat, which is found by 83 divided by 200, is 0.415. Looking at it on the normal curve, I would have 0.37 in the middle and 0.415 over here on the end, and I'm shading below or above, and that p-value is 0.094. It's approximately 9% of the curve. This is a z-score of 1.318. Technically, you could just draw the curve and put all your values on it, and that would work. One more thing I haven't shown you recently on the recordings is how to draw the curve. You hit stat, go over to test, one prop Z test, and go down to draw instead of calculate. It will draw it for you with the shading, and it'll give you your p-value and your z-score. So remember, if the calculator can draw it for you, you should copy it on to your paper for credit. Now if you have an error or dim mismatch when that happens, then maybe check your y equals, make sure there's nothing in there, and check your stat plots. Sometimes they can mess up the curve being drawn. Now I have to write my conclusion. We have to compare the p-value to that alpha equal to 0.05. So I conclude with a high p-value, because it's greater than 0.05, I'm calling it high. So with a high p-value of 0.094, which is greater than alpha equal to 0.05, I need to say that my p-value is either high or low, what it is, say compare it to 0.05, and then I need to write my decision. We fail to reject the HO. So if you fail to reject your HO, the null hypothesis, then you don't have evidence for the alternative. So we do not have enough evidence that the proportion of students who approve the new parking arrangement is more than 0.37. Some of you might question whether or not you should have evidence since your p-hat was higher than the previous, but the thing is that it wasn't high enough. Remember, every sample you take will give a different statistic. We want to find one that's so far away that it's extreme, and we have evidence to conclude that things have changed. This is not extreme enough to say that there's evidence. Okay, so moving on to the next problem, which was number 43, same page. It's about bullies in middle school. University of Illinois study on aggressive behavior surveyed a random sample of 558 middle school students. When asked to describe their behavior in the last 30 days, 445 students said the behavior included physical aggression, social ridicule, teasing, name-calling, and issuing threats. This behavior was not defined as bullying in the questionnaire. Is this evidence that more than 3/4 of middle school students engage in bullying behavior? To find out, Maurice decides to perform a significance test. Unfortunately, he made a few errors along the way. Your job is to spot the mistakes and correct them. So we have down here, he's got his null hypothesis. Looks like it's okay that p equals 0.75, but the alternative is using a sample statistic. So that part's wrong. And these numbers should be the same. They shouldn't change. It looks like he threw in his sample proportion for the alternative. So for this one, for number 43, same mistake number 1. For the alternative, it should say that p is greater than 0.75. Reading some more, they have the p equals the true mean proportion. We can't have a true mean, the true mean proportion, I guess, is okay, of middle school students who engaged in bullying. I'd rather you just say mean or true proportion, but saying mean proportion is okay. A random sample of 558 middle school students was surveyed. Looking back at the problem, yep, that's true. And then they have 558 times 0.797. So for the second condition, we're not supposed to use the sample proportion. We're supposed to use the original population proportion. To check the conditions, we should be doing, he should have done 558 times 0.75, which equals, what is that? 558, oops. 418.5, which is still greater than or equal to 10. And we don't have the failures. 558 times 1 minus 0.75, which is 139.5, which is greater than or equal to 10. And then we need to say at least 10. We need context here. At least 10 engaged in bullying and 10 didn't. Remember, you're checking to make sure your sample size is large enough. Then going on down, he never said anything about having the conditions met and being able to use the normal model. So that's huge right there. With conditions met, he can apply the normal model and do a one proportion z-test. He has the formula with the values plugged in. However, on the bottom of that formula should have 0.75, and it looks like he's got things flip-flopped in here. So we have to rewrite. He's got his p and his p hat confused, and he used the wrong value on the bottom. So for the z-score, it should have been 0.797 minus 0.75 over the square root of 0.75 times 1 minus 0.75 over the 558. Now I know most of you are not accustomed to using the formula, but you really are just looking at it on the formula packet and making sure that it's appropriate. On the formula packet, you would just line up. Here's your standardized test statistics, statistic minus parameter, over the standard deviation of the statistic. So here's your statistics, it's a sample proportion. That's your p hat. And standard deviation of your statistic, they're using the real p's. So plugging this in for the z-test, if I hit stat, go over to test, and do one proportion z-test, you had 0.75, and looking back at the problem, 445 out of the 558 were greater than. So calculate. Here's the actual z-score and the p-value. See what he got for his z-score. Negative 2.46, and I have positive 2.59. So remember, if we were to draw the curve, 0.75 is here. The sample was higher. And this little area right here is your p-value, which was 0.005. So p-value equals 0.005. Looking at the rest of this, it says the probability that the null hypothesis is true. No, we never determine if the null hypothesis is true or not. Is only some reason he multiplied his p-value by 2. Didn't need to do that. So he was just saying it was greater than. So we reject the null. None of this makes sense. This proves that more than 3/4 of the school engaged in bullying behavior. Now that he totally just messed up that bottom part. So what he wants to say for the conclusion is with a low p-value of 0.005, which is lower than alpha equal to 0.05, he should reject the HO, the null, and he can say that we have evidence, or he has evidence, that the proportion of middle school students who engage in bullying is higher than 0.75. Sounded like in his conclusion he was starting to write a little bit about what the p-value means in context. So as far as explaining the p-value, that's where we write, if the null is true, if the HO is true, there is a 0.5% chance of obtaining a sample, a random sample of 558 middle school students with how many engaged in bullying? I think it was 438 that engaged in bullying. Oh, 445. With 445 students that engage in bullying. Alright, that wraps up the first book problems from section 9-2.